Remember, hot and cold are relative terms. You know when water boils, it's very hot, but refrigerant boils at a much lower temperature. So the refrigerant can take on heat, change to a gas, and still seem cold. Again, the reason is because the two substances have different boiling points.
Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, our LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Well, welcome everyone. My name is Clifton Beck, and this is Did You Know? The ESCO HVAC Show. And man, do we have a lineup of information today, and some of the most brilliant minds in our industry to bring it to you. So we thank you all for being here with us, and we're going to continue our discussion on this HFC phase down. Still gaining a lot of momentum in the industry as people are starting to be more aware of what we're talking about and how it's affecting the industry as a whole. So before we dive in with Don Gillis from Chemours, I want to recap a little bit about our previous discussion on HFCs. Primarily, we were focusing more on the residential comfort cooling side, but we talked a little bit about the entire HFC phase down in general. So when we look at the HFC phase down, we're talking about international treaty that has been brought through and is being dealt with through the AIM Act on the HFC reduction side of it. And we have started our timeline. 2022 initiated the first stage of the HFC phase down, which is a 10% reduction in all HFCs. We're going to see an additional 30% once we get to 2024, which is really going to make an impact on HFC supplies. So with the Kigali Amendment, we began this phase down many years ago, and it's going to take a while before we get to the end of the path. But we are definitely on that path, and we are now seeing our HFC refrigerants starting to phase down. Consequently, prices are going up. So if anyone has recognized that there were increases of prices of refrigerants like R410A this last year, a lot of that has to do with that 10% reduction of virgin refrigerant. But it affects all HFCs. And so to maintain the current prices of refrigerant, we are going to have to increase the amount of refrigerant being recovered so that we can put that back into our refrigerant supply, especially for the service sector. Now, here is the thing that gets a little misunderstood when we're talking about the HFC phase downs. There have been some topics brought up about R410A and R404 and 407, some of these 400 series refrigerants that are not on the list, because this is Table 1 of the AIM Act that lists all of the HFCs that are being phased down. Here's the thing that gets misinterpreted. All 400 series refrigerants, if you go back to your 608 training, you'd remember that all 400 series refrigerants are blended refrigerants, so they are not a single constituent refrigerant. They're made up of a variety of other refrigerants. So we're going to talk a lot about 134A, we're going to talk about 143, which doesn't get mentioned very often. We're going to talk a little bit about 125, and we're going to talk a little bit about 32 real fast. So here is our current schedule. We're at the 90% level for 22 and 23. 24, we're going to drop down an additional 30. So the 30 plus the 10 will give us a 40% reduction. And we're going to continue down so that by 2036, we have an 85% reduction of all HFC refrigerants, virgin refrigerants, right? So why didn't we see R410A on that list? Well, R410A, we've discussed before, is made up of a 50% blend of R32, which is on the list, and R125, another one on the list. Here is where it gets a little interesting when we're talking about some of our commercial refrigerants, like our 404A. which anyone in commercial refrigeration has been using 404A as your low temp refrigerant for decades. The reason it's not on that list is because it is a blend of 3 different refrigerants. It is primarily R143A, which you don't hear about a lot, but it is on that list, R125, which we just talked about, and 134A, very small percent. 134A, R32, 125, 143, they're all on the HFC phase down, which makes R404 on our list as well. So today we're talking about our commercial refrigerants. Our primary refrigerants that we see in our commercial refrigeration is 134A in our medium temp applications and R404A in our low temp applications. So what are we going to do about those going forward, right? Those are going to be phased down because they are all made up of these single constituent HFCs that are on the list. So we have some really good friends of the industry that have committed to help understand this from a deeper aspect. So today we have Don Gillis from Chemours. Don, thank you so much for joining us. And Don has even really stepped out on the limb and joining us while he's on vacation in Florida. So that is some pretty serious commitment, my friend. So we welcome you to the show, and we are so excited to be here with you, Don.
Hey, thanks a lot. Great segue, Cliff. Appreciate it. With Chemours, thanks you. I appreciate you having me on. And yeah, what are we going to do with those old systems, gang? What are we going to do with those
There's
systems?
a lot of them out there.
Right? I mean, you know,
Yeah.
and I'm not here to beat anything up, but they can't all, we can't convert all those equipment over. So, you know, that's what we're here to discuss about. What are we going to do with those systems that are out there? So let's walk through this here. Let me see.
So we're going to learn a little bit about cooling down this curve that we're going to see, because it's going to be a learning curve. All of us are going to be affected by this learning curve a little bit. So the better that we educate ourselves, the more aware we are, the less of a confusion and a headache it will be as we approach it.
Absolutely. And hopefully by the end of this, we'll, with the help of others, we'll see how we'll try to take the pain points out of here, of what's going to happen. So I'm from Chemours, as we said, spent a lot of time with Emerson on the Copeland side, as many of you probably know. We do own the rights to Freon and the new refrigerants Opteon. And Chemours is not a household name yet, but they've been around.
Should be.
2015, we're actually a spinoff from DuPont, which is pretty well known. So that's where we are. So if you start to see Opteon, that's the new Freon, if you will. That'll be the new refrigerant you'll be taking on. So yeah. So as Cliff said earlier, just a quick high-level view here. Here's the AIM Act, or the American Innovation Manufacture Act. And as Cliff said quite well, 100% at the baseline on 2020. We stepped down in 2022, that 10% already. And you've seen what that did, the effects of everything, what were the allocations, what have you. Notice that 2024, again, that's going to go down another 40%, okay? 40% baseline reduction, down to 60% pretty quickly there. And I think we've all been in the industry long enough to know the writing on the wall. We've seen this for years when things like that happen. Obviously, I'm not here to be gloom and doom, but it is going to, you know, these are allocations, right, gang? These are allocations. So basically, it's what this is telling you. This is a roadmap of what manufacturers like Chemours can make. Okay, and that's the first thing. I do want to shed a silver lining here, though, if there is one. And that is when we talk about this 40% drop down, this is HVACs straight across the board.
Right.
This isn't just refrigerants. This is anything to do with HFCs, foam insulation, anything that has HFCs in it. So it's, you know, the manufacturers like Chemours and the Honeywells of the world are going to have to make a decision what they want to make the most of, because they're going to have this allocation, right? And this is what that allocation looks like. I only put a couple slides in here, as I was telling the guys before we went on, because I wanted to set this up. I know you have a pretty educated audience, but I wanted to show you just an idea what this looks like. So take a look at 507s and 404As. Almost 4,000 right here, okay? So moving fastly down to the right here, the 449s and the 448s, if I'm only allotted so many GWP, my metric tons, what do you think they're going to do? You know what I mean? If I can sell more of this than I can here, I mean, business is business, right? I mean, let's just be really honest about it. I mean,
yeah, because we're not talking about pounds of refrigerant. We're talking about refrigerant based on GWP. So if I talk
yeah,
about half the GWP of a one refrigerant, now I'm talking about twice the quantity that I could utilize.
exactly. You only
That
have
is a
so
great
much to
point.
put in that bucket, right? And
Yeah,
you're going to try. If I can sell 100 pounds of this, and I can only sell 10 pounds of that, well, I'm going to sell 100 pounds of this.
sure.
It's just good business, right? So, and again, I'm not here to be gloom and doom. We've been in the field, all of us, for a very long time. It's all about education here for me.
That's exactly
So
right.
going down to the next slide here, what is it, just briefly on HFO molecules? You hear all this term about HFOs, HFO
Yep.
blends, and those kind of things. So this is going to be a high level view, HFO molecules. So on the right are HFCs, the hydrofluorocarbons. Okay, you can see the single bond there. Moving to your right is the HFOs, the olefin. Okay, and olefin by definition is this blue circle here, or this gray circle here. Olefin, by definition, is two carbon molecules bonded together. And when you put two carbon molecules, olefin, together, what they found, the scientists have found, they break up easier. Okay. If it's closer to the earth, double bonded is actually stronger. But as it goes into the atmosphere higher and higher, it becomes more brittle. So really, everything has a GWP. I mean, everything but ammonia. But even CO2 has a GWP, right?
Sure. Yep.
They're very low. Even your Y2, YFs have GWP.
Mhm.
But this gives you an idea. So, for example, 134A, we all know what 134A was in our cars for years, a lot of medium applications. The atmospheric lifetime for 134A approximately is about 14 years. It stays in there. GWP is 1430. When we look at the 1234YFs, we're talking about 11 days. And that's really what it boils down to. It's not that it doesn't have GWP. It's just it breaks up a lot quicker and it goes into the atmosphere a lot faster. Okay. So the difference is, and 1234YF, and I know now everybody knows this, 6-7 years ago when I was at Emerson talking about it, it was like a deer in the headlights. This 1234YF is going to be key in all your blends moving forward because of this low GWP. This is based on the AR4. And AR4, not the AR5, but the AR4 is what that's telling you. That's 100-year look at it. Okay. It's based on 100-year look. Okay. 9 out of 10 cars, fun fact, in the USA are used 1234YF. Okay. That's what's in the car.
Yeah, Don, if I could just chime in real quick, because I get calls from teachers all the time, and they're hearing about HFOs. And that really does scare them, because they're like, HFOs, they have hydrogen, fluorine, and oxygen. So one thing I just want to stress is HFCs contain hydrogen, fluorine, and carbon, and HFOs also contain hydrogen, fluorine, and carbon. And the only difference is that double bond that you mentioned. So there's no oxygen in an HFO. All right. So I just want to clarify, like I get calls from teachers, just saying, wow, what, I'm teaching this to my students, and I just want to make certain that I know what I'm teaching. So I just wanted to chime in. So it's that double carbon bond. There's no oxygen in there.
No. Love it. Because I try to do this as best I can to the definition. This isn't the world somebody in a truck or a teacher lives all the time. So it's a great point, Eugene. The olefin is exactly what you said. We're simply telling you that you have two carbon molecules bonded together right there, which makes this more brittle when it gets up in the atmosphere. It breaks up quicker. The difference between 14 years and 11 days, like we said, those are rough estimates.
Pretty significant.
Some of them are worse, by the way. So I tried to do this slide as best I can because I know we're limited time, but I made all the boxes here. I put this letter over here today, A1 refrigerants, everything in blue, everything in the orange, if you will, is A2Ls. All of these, starting from left to right, is your low temperature, medium temperature applications for R22. The same thing can be said about the 404As and the 507s. And then you get into your AC, screw chillers, refrigerators. And then last but not least are, air conditioning units. Okay. So walking through this, the XP series is a non-flammable. It's still Opteon. This is the new refrigerants, okay? The blues are your replacement refrigerants, A1s, right? And the A2Ls are for only a new equipment, okay? So what is our option for all those R22 systems? Where are we going to go with this? The GWP on that is 1760. Well, we've got 449A, 1282 under the GWP, okay? In the lab, it's referred to as XP40. So don't get all,
Sure.
I don't want to muddy the water here, because we're all going to know. You all know this already. When we start getting in the trucks and putting it in there, that's what we're going to refer to it as. And moving over to the 404, 507 applications, still again, 449 is applicable, okay? And you can see the difference.
Okay. Yeah.
Almost 4,000 GWP as compared
drop.
to 1282. That's a big deal. And when I show you later the efficiency improvement on that too, it's a kind of a win-win situation. So I'm going to try to make this as painless as possible. And then we also have 452A at 1945 GWP. Moving down to our 134As, we're going to be talking about 513. Now, 513, for whatever reason, is not really discussed with a lot of people, which confuses me.
I have not heard a lot about 513, so I'm really curious.
Well, I was kind of spoiled being back there when I take my walks at Emerson and go back to the labs where they're testing the compressors. You would see all these different numbers on the grease boards in the chambers, right? You've been there before, Cliff. So, the 513s I've seen for at least 6 years or so. It still hasn't got. And you're going to see this too in cascade systems if you're using like CO2 and low temperature. Okay. You're going to see that kind of thing. It's very, in fact, we have a store in Dayton, Ohio. In fact, it's ironic. Chemours was involved in it, called Gem City. If you ever get a chance, Google it. But it's actually a first of its kind. It's kind of a guinea pig. It was a food desert in Dayton where they had moved out. People had to bus to get grocery stores in one part of Dayton, Ohio. And it was a trial. We donated, Copeland did, Chemours did, donated all the materials for this to bring this and into that area. And on the condition we could use it as kind of a lab. So I've been in this rack room many times, but it's just simply 513 booster system. So the compressors are actually sitting on all the inside the store on top of all the units. It's very unique.
I'm seeing an ESCO roadshow.
It's a big deal. It's a huge deal. It's a big. I remember walking through it many a times with hard hats on when it was still a skeleton, if you will. So, but anyways,
it's a great application because now we're showing over a period of time how well it's working.
It's a very good. It's a very big deal, and it's not exposed enough. And I told Brandon the other day, my manager, I said we really ought to blow the horn on this and promote this more, because I don't think, if you're not privy to those inside stories, you just don't know about them. And it's a big success story. But and then we move over to air conditioning, 410A, and unfortunately, you notice there's no blue box there.
Oh yeah, that's the struggle right now.
Yeah, that's the big one. Anything that's been approved by the, let's say, compressor manufacturers and those kind of things on their bulletins, it's just not there yet. Okay, so we do have the 454B, which is kind of I think every OEM manufacturer, with the exception of like Daikin, for example, is using 454B. So that seems to be the flavor that everyone's going to go to. And then we have over here for the AC chillers, refrigerators, our 1234YF. Down here we'll have 448A, 454C. And the difference between these 454s, by the way, B, A, and C, is just the chemical blend. It's the same chemicals. It's just a different blend to get your different temperatures is how that works.
Sure, because they're they're 32 and 1234YF. Just in different capacities. And it makes sense after you explained it about the allocation based on GWP. Because now if we can take 32 with a significant amount of 1234YF, man, you're really affecting the price of the refrigerant because we're changing the allocations of those HFCs.
Well, and to that point, gentlemen, if you look at the XP10, the 530, the 513A, I mean, that has a GWP of 573.
That's great.
And 513A, and correct me if I'm wrong, Don, I mean, that's a blend of R134A and 1234YF. So
You
those are mixed, close to a 60-40%. I think it's, a little bit lower, like 58-42, somewhere in that range. But yeah, so that 513A is really like it's a mixture of the 1234YF and 134A, and look at the GWP. Yeah. So now for the same applications, you now have a refrigerant with a GWP lower than 600, as opposed to using the 134A, which is at 1300.
Significantly less.
It's so funny. Well put. It's so funny you mentioned that, because I wouldn't have talked about that. But these future blends, and I used to say this in class all the time at my prior job, is pay attention to 32 and 1234YF. Those are going to be huge players, especially that 1234YF. It's going to be about in every blend. And you're right. I hate to use the term watered down, but that's what it's doing. The other chemicals like 134A, that's getting your capacity, and you're throwing that other blend in there, that 1234YF, getting underneath that low GWP, but still getting that capacity you're looking for.
Great stuff.
Yeah.
I just want to point out before we get off this slide that all of these refrigerants that you're pointing out up here are SNAP approved for those applications. So 454B is SNAP approved, right, for air conditioning. YF is approved in chillers, but as you mentioned, for the 410A, there is nothing that is SNAP approved for a retrofit for existing or legacy equipment in that application.
Yep.
Exactly. Thank you, Jason.
We do have one question that came in, Don. I kind of hate to move from this slide because this is really good stuff here.
It's busy, isn't it?
Yeah. And for everyone that's joining in, let us know in the chat where you're chiming in from, because I'm sure we got people international today. This is a hot topic for a lot of refrigeration folks, and this will be very important going forward. One of the questions that came in, Don. So on a new installation, a walk-in cooler that is going to have 404A. It's a 404A design system. On a new installation, if it is uncharged, could it be substituted with a 452A even on a new installation if it didn't currently have refrigerant in the system? And do you have to do anything with the expansion valves in a conversion like that?
So the 452A is a unique animal, and if you lay it out on paper, like any kind of software, like PSS on the Emerson software, you can design your equipment and stuff like that. It lays almost the template exactly like 404A. Unfortunately, pay attention to this GWP 1945 on stationary equipment. That GWP is too high. What I'm getting at is 452A is primarily for your transportation vehicles. Okay. That's what this is used for. Because I get those calls and emails from friends in my past career all the time. Tell me, now that you're in this industry, why in the heck can't we use 4? Because everything matches. It looks good. And they're right. But unfortunately, here's the hang up right there. And that's the problem. This is primarily used in transportation. Because of the smaller charge, you're allowed a larger GWP, right? Right. On the larger charges, we have to lessen that GWP, i.e. supermarkets, right? Yep. The more possibilities for leaks in the system, the lower GWP. The more pounds, the lower GWP. So in those small charges for like a truck, refrigeration truck, this is acceptable, okay? That's your answer for that, all right?
Man, I love it.
And by the way, that's why 449 is used on new installations also. You can use it. You're starting to see the coils now come out stamped on them. 449A also approved. Okay. Nice. You're starting to see that. We were just in Tucson, as I mentioned earlier, and a couple weeks ago, and some guys are saying, I'm already seeing this one coming in on the coils on new equipment. So you're telling me this? And the answer is yes. So we'll see if that changes, but that's the way it is today. Okay. So what do we want to do? What's our goals here? Okay. We can't shut these stores down, right? In a perfect world, equipment goals are, hey, first of all, keep the existing equipment running, right? I know you've been there, Cliff, and probably you too.
Half of my life.
That's a big deal, right? I know you a little bit more about your background, Cliff, so I know you've lived that world.
If it wasn't for old junk, I wouldn't have had a job.
So the least path of resistance, that's what we're trying to do here. Simple and easy to service, minimize cost, keep that maintenance easy to understand, and the energy. And something we don't talk a lot about here is total equivalent warming impact, or TEWI. Okay. And what that's telling us on the TEWI, and I know you guys know this, but for those listeners that may not know this, it's really about weighing out, even if something has a lower GWP, and I'm not here to sling mud, sometimes in a bad geographically area, a hot temperature, if you will, if you're in transcritical on like CO2, you're actually putting more emissions in the air than you are saving on the GOP. So it outweighs itself. So that's what that means. And then long-term compliance. We want to make sure this is going to be okay for a while. On the refrigerant criteria, safety of the system, the toxicity, the flammability, the pressures, okay? Are they normal, what we're used to seeing? Not like some of the stuff coming out, that you're going to see that maybe you're not familiar with, the 2,000-pound pressures and what have you. Then the acceptable performance match, that's a big one. And then comply with the current future regulations. Is it compatible with existing components and materials? And that's what we're going to talk about today, okay? I threw this in earlier. I talked to you guys about it. I wanted to set this next slide up. This is just a snapshot of the CARB. Again, keep in mind, we're talking about retrofitting today, and there's a little more leeway there when you're retrofitting existing equipment than you are, new equipment coming out. Right. So keep that in mind. We're really focused on retrofitting. So 449 at a glance, the GWP 1282 compared to 3922 for 404A, or 18 with 22. No ODP replaces 404A and R22 and others, actually 507. POE oil, that's a good deal. ASHRAE 34, again, it's A1. And here's what Eugene and even Cliff mentioned earlier. Here's the composition of it, okay? You've got R32, R125, 1234YF, there's 1234YF, then you have 134A. That's kind of interesting there.
Yeah, because that's a blend that I haven't really paid much attention to.
Yeah. I mean,
that's
really
a lot of YF.
Yeah, and that's what keeps that GWP down. I know I'm just preaching to the choir with you guys, but even your listeners. But look at this fun fact right here. Look at these first two. Does that look familiar? That's 410A right there.
Let's see. Little 410A, little 134A, a little YF.
Yeah,
boom, you got some magic.
Exactly. Hey, I never thought about it like that. A little 410A and a little bit of 134A and dabble in like you're making a soup or something here. So,
John, that's actually really interesting, because when you look at an R22 replacement, namely 407C, what is 407C, right? 407C is a blend of R32, R125, and R134. So it's not like we're dealing with 22 million different refrigerants. We're really dealing with a handful of refrigerants. And it's really the recipe. How are we putting these ingredients together to make the final dish?
I did a class one time, and I called it I called it the soup bowl of refrigerants. And so I started on the class just, like the chef, mix refrigerants. I was like, this is R400 series refrigerants. And they're like, what are you talking about? I'm like, all of our R400 series refrigerants are carefully blended recipes.
So we're kind of like a bartender for refrigerants.
Absolutely, we are. Now, don't go mixing them yourself. And
quick disclaimer, right?
Blends are made. I've got some 410. I've got some 134A. Let's see, 6 seconds ought to be about 25.7.
A couple of Mississippis,
It doesn't work that way.
Yeah,
blends are made in the factory by engineers, not in the field by technicians.
Exactly.
Don't try this at home.
and not to get in the weeds here, but just to point out to you, in case somebody's watching, a chemist or something like that, which I'm sure there isn't, but the actual larger percentage is supposed to be in front when you read these from left to right, just so you know. I just didn't correct this. So
if you read
anyway,
Hebrew,
good stuff, guys.
John.
What's that?
If you read Hebrew, it's perfect.
That's
from
exactly
right to left.
I find these composition blends though really interesting. So you're going to see this common theme throughout my presentation where I show you what's actually, and I don't want to go down a rabbit hole here, but this R125, when it comes to GWPs in the 410A, this is like 2/3 of the GWP when you remove the R25. And what's it really doing? It's a fire deterrent. That's really what it is. You see it in fire extinguishers and stuff. This R32 runs hot on the discharge line, if you didn't know that. This cools that down and brings that temperature down, because once you remove that R32, that discharge temperature raises quite a bit. It's in the 208 temperature on the discharge line. So just a fun fact there for you.
It is a good fact.
That one time, using R32, and then they just started adding 125 until it became
an A1.
Yeah, exactly. No, yeah, that's great. That's a great point. That's exactly the point. R25 is the reason. Once you remove that, then we start to see our A2Ls. You're exactly right. Yeah, good stuff.
Fascinating.
Okay, just a real quick look at 449, the base of it again. Again, repeating myself a little bit. 1234YF. Okay, it lays out, for the reason it's in cars now, the PT chart almost identical to 134A, as you can see right here. Okay, it's used again in 9 out of 10 cars made today. Thermally stable under extreme conditions. Capacity and efficiency very similar, almost identical to 134A, and there's no flame propagation. Okay, so that's cool stuff. Really good stuff. So that's really the common technician probably won't talk about this a lot, but us instructors, us educators will get to know this really, really well. This will be, without a doubt, a household name in another couple of years, if not.
Yeah, that's a primary refrigerant. It looks a whole lot better than I'd even realized before. So I'm glad you're doing this for us, Don.
Yeah, no, you're more good, happy to do it. So 449 application, what's that going to look like? We can do reach-ins, cold storage, ice machines, supermarket racks, and if we can even do cascade systems, as on like your your booster systems, if you will, industrial processing and ice rinks at this time. Low and medium temperature applications also used in new equipment, coils approved. We'll see how that shakes out, but as of right now. So let's look at R22 now. I started with R22 because it has a couple more hurdles than when we go into 404A, and mainly because of the oil. Okay,
sure.
When we're changing this, but really, if you look at the red right away, not to cut to the big point here, but this is going to be almost identical what we did from R22 to 407A, basically.
Yeah, absolutely.
So the R22, you have a few more steps, and only because you have to change the POE oil from the mineral oil. So what we're going to ask you to do is, okay, and these are the pain points right here. This is going to be the biggest one, I promise you. Review the retrofit guidelines, obtain the baseline data while running on R22. And you all know, everyone on this call right now, that's the people that are here, Eugene, Clifton, and Jason, all know. We always want to know what our baseline is. We don't know where we're going if we don't know where we started, right? So we change that oil out, and then we put the POE oil in with the 22. And what Chemours is going to recommend here, we need at least 2 oil changes with filter changes, okay? Yeah, once that's completed, okay, that's highly recommended. We have to do that, okay? I know it's not easy. I get that, but it has to be done, okay? Once you get out of that, you'll see how easy it is, okay? Recover the 2, all right? You're going to need to look at, we're obviously going to change filter dryers. And here again, here's where we have a little bit of a hurdle. We need to change those critical elastomeric seals, better known as O-rings in the field. I'm not going to say elastomeric seals again, okay? It's always going to be O-rings for me. And the reason for that is when you degas things, those O-rings shrink.
Sure.
Found out not too long ago that those O-rings, when they're made like that, they take in consideration when that oil hits it, when they expand. So years ago, when we were moving over to like new 22 and 407Cs, we were thinking, at least I was, and the people I hung around with years ago, we were thinking the rumor on the streets at the counters are like, no, I'm not going to go to that stuff. It's eating the O-rings. It's not. It was the degassing that was shrinking those O-rings, causing those leaks, okay? So you have to replace those, unfortunately. Evacuate the system, do a leak check, and then charge with your Opteon XP40 startup and monitor. leak check, label system, and optimize your set points if needed. Again, this is identically what we were doing years ago with R22
Nothing new.
407As, the same things we were doing before.
Proper procedures, man. If we would all follow proper procedures, we wouldn't have to preach doing proper procedures, you know?
Exactly. And I promise you, this is the most difficult one. When we get into 404A, you're going to see how easy it is compared to the R22. So again, to recap, we need to convert the oil over. We're going to ask you to at least change the oil twice. After you drain the mineral oil, put the POE oil, let it run, change the filters again, ran more POE oil, and then can remove the R22 and go in with your, replace your O-rings, change the filter dryers, and then start to charge the system. Okay.
Don, one of the questions that came in, do you know, is it capacity-wise, is it a pound per pound replacement?
No, it will not be. It will not be the same pound per pound. Okay. It will be, you'll have to, it just, if you remember like the new 22s and the MO99s, the weight will be slightly different on that. Sure. I don't have that off the top of my head, but it's going to be different because of the blend difference on that. So it's a great question though.
I think we recommend 80%, right? Start at 80% and work.
Yeah, exactly. Yes.
Yep.
Great point, Jason. Yeah. Great point for that. Because I don't mind sharing it's always a learning curve. I remember the first time I reached out to iCore years ago and said, hey, I'm putting this new 22, something's not jiving up. And some of you might know Matt McKinney, and he called me back and he said, hey, that weight difference, let me send you something real quick, so I had to, figure that out. It was a trial and error thing to understand what was going on there, but a great question though.
So Don, so Don, what are your suggestions if, let's say you're on a system and it was operating with R22, you lose a compressor and now you say, okay, we're going to change the compressor out. And while we're doing that, we might as well, convert, retrofit to XP40. So I'm a technician. I get out on the job. I can't get baseline data because the system's inoperable. The system's not running. What are your suggestions as the refrigerant guru to, for a technician in the field, being that it's not pound per pound, being that the performance data is, how similar is the performance data? So you're saying, what tips do you have for us?
Perfect. And I'm going to show you this in the next slide or two. And the easy answer is I want you to all remember Opteon.com. You'll have all your sheets for that comparison on what the pressures look like for R22 or 404A and what that's going to look like. And all you really need to know is what are you looking for the evap temperature? So if you want to be 20, it will tell you what you were at the pressures on the 22, and it'll show you where you should be at on the XP40. That's a great question because it happens all the time, right? So that's what we're going to do you're going to see that here in a slide or two. It's probably the next slide, but I believe I have that chart in every one of these conversions we're going to talk about today. But remember Opteon.com on that, okay? Just another thing, these are just quick examples. I'm not going to spend a lot of time on here. Identify locations and sizes of your O-rings, identify components that will need to be changed. And I just put down a handful of examples. I know it's probably more than you need to know, but just in case, we refer to it as a two-step process. Okay, here's the chart, by the way, Eugene. So if for some reason this goes down, this is right off the Opteon.com website, by the way. So it's a wealth of information. It's all free to you. It's good stuff. So you can see after converting the R22, if you have that, go over here, look at what you are. So locating the desired average evaporator temperature or the 22 evaporator pressure on this chart and determine the new set point required for the XP40 in order to achieve the equivalent average evaporator temperature. So if you're running a 20 degree, this could be a walk-in, of some sort, the evap temperature, your box temperature would be probably around 30 then, but 43.1 pressures on gauge pressure on R22. The gauge pressure, therefore, would be 48.5 on the XP40. Does that make sense?
That's awesome.
Do you even see... So since I know we're going to have a little bit of a glide on that, is there any reason to even readjust the expansion valve and going from 22 to XP40?
Very, very little. We're not going to ask you, as you noticed in there earlier, because that's going to change in the next thing when we talk about 404As. You notice that we didn't even change the TXV or the power head on that. Okay, so it is your very little adjustment, if at all.
Awesome.
Okay, so that's almost going to be, and you're going to see that too with the 134A to 5132. I've always disliked. I don't really hate anything, but I dislike the term. I think we all do, drop in refrigerant, because if you don't have somebody that goes to training and gets educated by you guys, they somehow get that misunderstood. But 513 is, you don't really have to do anything. I mean, it is just perfect, So anyways, but this is that chart you were just kind of asking. That was that question that came in there. Hey, great question, Eugene. So let's look at 404A now. Okay. Now we've talked about 22, the 404A systems out there. This could be 507s also. I just did one. 404As. So what does that look like? Review the retrofit guidelines as we talked about. Get the baseline down. Recover the refrigerant. Change the filters. Evacuate the systems. We need to do a TXV adjustment guidance. You're going to go to Sporlan or somewhere like that and look at your guidance. I had that chart in here. I removed it because of time. But anyways, what you're going to find at on the XP40, the 513, the 449 is, you're probably going to throttle that TXV all the way down. Okay. You could take it all the way down. Okay. The worst scenario on this is going to be to change just the power head, not the body. But if you're in the hotter climates like South America, we get a lot of reports down there where they're not even changing the power heads. But the reason for that is to throttle that down is for don't take a chance on that liquid flood back and slug our compressors. That's the reason for that. TXV needs will be in the adjusted post retrofits. In many cases, it's in fine print here. R22 or 449 power elements should be installed for the 404A or the 50C valve body. Keep the body, change it over to either a 449 or an R22, and you're dialed in. Okay. All right. You're still going to see that kind of choked up a little bit or clockwise, starving it just a little bit different than what you had at the 404A. That's the only difference there. Okay. It's already POE oil, so that problem's taken. You don't need to change any gaskets. And to me, as a technician, like you all been, that's on this call right now, that's good stuff.
Shoot,
you know what I mean?
Time.
This is a way out, okay? Mr. and Mrs. Jones or Bob, the manager of the store, well, how long do you think it's going to take? Not very long. You know what I mean? We're going to make this as painless as possible. We're not talking about changing coils out, okay? Leak check, label the system, and optimize your set points. Again, no oil change, no seal replacements, TXV adjustment, and it talks about low temperature demand cooling considerations. But talking to Dr. Chuck and Andrew in the chemical labs, they're telling me that seldom ever applies for anything that they've ever seen. So, but more into that later. 449 TXV adjustments. I threw this in there because you guys are geeky. I mean that in a nice way.
Oh, yeah.
Suction pressure.
With loving admiration.
449A TX. I was playing with this on the plane, so it made sense to you. TFE adjustment versus 404A. Suction pressure difference from the same average of temperature. Low temperature, about a 4 PSIG lower on the 449. On the medium temperature, about 7.5 PSIG lower. Okay. That's what you're looking at. When the suction pressure delta is between 5 and 6 PSI, there should be enough adjustable range in the spring to reach target superheats. The 5-6 PSI delta is based on experience. It's not a hard line as to what is acceptable. It's just from our past experience documenting data from past applications, okay? Also need to look at the net refrigeration effect difference between the refrigerants. So 404A retrofits, typically we recommend to change the power elements to a 22 or 449A, depending on where you're at. But like I said, I just was told this like 2 weeks ago from one of our folks. We're actually incorporated into South America too as part of my group. And they're having great success with just keeping it the same and just starving that TXV, if you will. Okay.
Sure. Now, Don, with the TXV with the 449A power head, is it primarily certain manufacturers that are utilizing 449 power heads yet? Because I haven't seen any, but I'm sure they're going to be adopted because that's a very, very good refrigerant.
Yeah. So I took it out, and now I feel like I should have kept it in. But Sporlan has a nice spreadsheet on it, a nice sheet, and I'll send it to you guys after the call. And anybody else that wants it can contact you, and I can get it to you. If you go to the Sporlan website, you'll probably be able to pull it off because it's literally a graph we took from there. But it will show you the size and what number and everything you're looking for. And I'm not here to promote Sporlan or anyone else. I just know for a fact they have it already. Okay, that's the only reason I'm mentioning them. There could be others. Okay,
I figured that they would because back in the R12, back in the CFC phase out, that was one of the things that we ran into was power head replacements, and there were some companies that were on it like really quick. So that's awesome to see that they've already taken that initiative.
Yes. And not to repeat my here, I explained to you guys here, like I said, I know your audience is very educated. This is the we talked about earlier. We're repeating ourselves what we did with R22, whether it's running or not running, like Eugene suggested. If you don't have a baseline, this is all on Opteon for every application or conversion over. Okay, so you can find that here. Let's talk about Glide just slightly. Okay, I debated whether to put this in here because I think everyone understands Glide, the single component or the azeotropic blends. We don't have Glide, like i.e. 134A, okay, or azeotropic blends like 410A. It's very minimal. We don't even talk about it, right? And then we get into our blends here, and you saw that formula earlier, the typically just called blends. We're going to have different boiling points as we go up here. The difference between the bubble and the dew, as we all know, is in fact our Glide. Okay, enough of that. That's all I'm going to do with that. All right. And this is some examples of what Glide looks like on refrigerants we use today. So you can see, I want to be very transparent here. 449 has about a 7-degree Glide. Yep. Yeah. So I want to make sure we're all aware of that, though. But what I did want put in here extra as I was traveling is Emerson's, again, PSS software is free to download. You can go there and do the download and put in everything, the whole application, your system in there, the compressors, what your midpoint is, what your dew point is, and you can calculate that up and figure out where you're going to be at and where you need to be adjusting at and those kind of things. And it's all free. I mean, they even have it on Copeland Mobile. So just a plug out there for Emerson's only because I used to actually give this as a presentation. So it's there if you need it. It's very helpful. Use it, and I know the guys at Chemours in the labs actually use it too.
Oh, absolutely. Handy tool, especially if you're doing any kind of, set point readjustments based on the refrigerants that you're using. So, there are some systems that are, especially when we get into EEV controls or, systems that are based upon, superheat calculations, that Glide can be a factor to program in. So not all systems, but there are some out there.
A lot of them are using midpoint, and that app does do the midpoint, which is a really big deal, especially if you're building a system. Yeah,
exactly.
Yes, you're exactly right. Midpoint is very popular on the system as a whole. Yes. So let's talk about 134A, going to that 513. I've been talking about that kind of unknown right now. It's out there already. It's in your wholesalers. I see it all the time. Okay. Optical balance properties. Okay. Meets regulatory requirements. No ozone. SNAP listed, as Jason mentioned earlier. Okay. 56% lower GWP versus 134A. That's huge. Azeotropic blend. So there's no temperature glide. Big deal there. Extends life of the existing equipment. So that's what it's all about. We don't want to throw those old systems away. We can still got a lot of miles in them. Let's continue this here. We might get into a situation where we find that it's a better deal to keep the equipment. It's still good, but maybe get away from that older refrigerant because maybe the cost factor. And I'm just assuming, but you guys are as smarter than I am. You've been. This isn't our first rodeo with changes.
Don't say that.
That's right, buddy. You're here because we need you here.
A1 classification, ASHRAE 34, commercially available and OEM approved. Emerson, Bitzer, Tecumseh, all those good majors,
nice.
OEMs and stuff like that. Here's the formula for that on the 513, 1234YF and 134A. 56% 1234YF, 44 134A. So we still got the 134A in there, but with that 1234YF only having a 4 GWP, that's huge, man. That brings it down quite a low. So very attractive, very, very attractive moving forward. Guidelines, pretty much. This can't get any easier. And I know I work for Chemours, but it really can't get any easier because, quite honestly, I was talking about this at Emerson. Okay, this is the booster system I was talking about at Gem City. This is where you'll see this in Cascade Systems when you talk about CO2 options also right now. So
there's a lot of 134A boosters out there already.
Yes,
over the last 10 years. So
yeah. So this is kind of a big deal. In fact, you remember the simulators we had at Emerson, Cliff, when I really thought they were going to come back and tell me 449 or 448 was going to be the refrigerant of choice. I made an effort a couple of years ago to say, well, when this CARB thing started hyping up, before we got into the AIM Act and before we signed the Kigali Amendment, hey, should we look at this so we don't get flagged at the California border,
exactly.
shipping those trainers out?
Yeah, we're going to ship these at some point. So let's think ahead.
Hey, you have to, should we take a look at this? And I said, yes, we should. The engineers came back from the lab a couple days later. Corey was his first name. And he said, hey, look, 513 is going to be the least path of resistance. We're not going to have to change anything really on it. We're literally going to have to adjust slightly the TXV maybe, and that's it. So this has been around for a while. So recover the 134A, change the filter dryers as always, evacuate the system and leak check. Follow TXV adjustments. TXVs will need to be slightly, I highlight slightly adjusted, if at all. Okay. Charge with Opteon 513, start and monitor, leak check, label the system, everyday business and everything we've done all our lives, optimize set points, and you're off and running. I mean, how much easier does it get? That's pretty good stuff, man. I know I don't like snake oil, but this is good stuff. This is why I really wanted to come on here when we were talking a month or so ago.
Oh yeah.
Is there any topics you want to talk about? Yes.
Boy, this is a big one.
Understood about. Yeah. I mean, we're all about making people's lives easier, right? What you all have spent time in the truck. Eugene, Clifton, Jason, all of us. That's the people I think about. How can I make? I don't want to sell a bunch of stuff that's just to be selling stuff. This is stuff that'll make my life, the trucks easier. Because you keep in mind, you may have family in the field too. My oldest son is in the field. So I want to share these kind of things with him. You know what I mean? Sure. So to make, let
me make your job easier.
Yeah, exactly. Yeah. It's all about trust and educating people. That's really out there. Yeah, it is. And
there's a ton of 134A applications.
Yes.
We spend a lot of time talking about residential comfort cooling. And the reason I wanted to bring you in and bring this conversation in is the amount of 134A based commercial refrigeration systems. You haven't walked through a gas station or a grocery store without walking past a 134A unit. It is in every commercial medium temp application. There are some that are using 404, but primarily 134A is what you're going to see in your coolers.
Yes.
So pretty significant refrigerant and capability.
Yeah, and I shouldn't assume, but great point. Just to reiterate what Cliff said, 513 will be a medium temperature application. Yes, great point. I should have mentioned that earlier. But yeah, you're right, Cliff. This is this is going to be a like for like, pretty much. This is the new one.
This is what I would carry on my van.
Yeah, if you're using 134A and you have a lot of systems out there, it doesn't get any easier. There's no TXV, there's no O-rings, there's nothing. It literally, once you get it cleaned up and change the filter dryers and do all the things that you normally do on any system, even when you recharge with the refrigerant, you're basically just dialing it in.
Yep.
Okay. All right, next slide right here. I'm actually at the end. I can't believe it. Mm-hmm. So we've got all kind of information out there, the tech support stuff like that. Data, go to Opteon.com. I've got to do my shameless plug here. And then tech support, Jamie Hale and the guys, great crew out there.
Good
you can
people.
Call us anytime, email us. They're really quick to respond. I've had Jamie walk out right in the middle of a conversation before, and I took it personal. No, just kidding. But he takes those calls. Everybody's on the calls. They're really good support. They do care. They'll come to your job sites. We're all about educating, as ESCO is. And, we're all working together for the common goal. Okay.
That we are. My goodness, Don, that is a lot of good stuff. There are a few questions out there. If anyone has any other, hop in. One of them doesn't particularly pertain to this one, but I wanted to make sure to give them some direction. It was a question about equipment diagnostics. If you're talking about residential equipment, we have a good video from a couple months back with Reem where we're talking about technologies and residential air conditioning equipment. So, Keith, that's one that you can follow up on and has more information on that.
I do have a question real quick, Don. On the 513, is it the pressures, temperatures very similar to the 134A as it is? I mean, close enough where we don't have to, like, if you have pressure controls or things, they don't need adjusting?
Exactly right. Yeah, exactly right. It is literally, again, going back to that drop-in term, it is as close as you can get to anything I've ever seen. It is a miracle. I mean, it's amazing. But you saw the blend. I mean, it's still quite a bit of 134A in there. Yeah. It's a great question. It is the least painful conversion that I know of, for sure. And it's just not talked about very much. But with the allocation chart we showed earlier, kind of the world you live in every day, Jason, it's going to become a huge player. So it's better to get the word out now and start planting those seeds, because it's going to be someone's best friend in the near future.
As you mentioned, the allocation, manufacturers are going to realize that instead of just selling straight takes of 134, if I cut that in half, put some YF in there, I can double the amount of 513 I'm selling.
Yep. Thank you. Yes, that is exactly very well. That's the whole game of it. Like it or not, that's what's going to happen. It's just the nature of the beast. They're going to, again, going back to that GWP by metric tons compared to the emissions to CO2. That's, you're only going to be able to sell so much. There's only so much in the bucket. So if I can only send 10 of these and make the same markup on them, or 30 of these, what are you going to do? You know what I mean? It's just common sense. Not to mention, you still have, the EPA and stuff that are going to be hounding you about those high GWP refrigerants. Yeah, so it's better to start thinking ahead of time to have the conversation with the store manager, store owner, whoever it is. And that's the way I like to do it. I don't know about you guys. I know you guys were the same way. I loved telling the customer in advance, not surprising them. Hey, just a heads up, not trying to sell you anything.
Here's the options.
This isn't the world you live in. You work at GM. You don't work at, educate them, because they appreciate that. You know what I mean? So
to your point, Don, when you were talking about, would I rather make 10 of these and sell them, or 30 of these and sell them, and we'd rather make the 30, obviously we satisfy more customers that way as well. If we only made the 10 and sold them, we're out. And there's a bunch of people looking. If we make the 30, at least we can satisfy demand that way.
Exactly. Not to mention, again, going back to it, whether you believe in, global warming or whatever, I'm not here. Remember the letter potential. Refrigerants aren't designed to release it in the air. It has the potential only if you release it and not do good habits, what I mean? And correct your leaks. It's not designed to release in the refrigerant. That's why the word potential is there. It has the potential if you let it go. So good practices. And again, not on this topic today, but you're going to see a lot of education. I know you guys are doing it already on recovery. Recovery is going to become your best friend, right?
Massive.
You're going to see a lot of companies, as you mentioned, on the equipment for maintenance and things. They're going to start recycling, refrigerant and keeping it so that they have the same. So I recover the refrigerant out, I make the repair, whatever. I recycle the refrigerant and reuse it. This way I keep it in my inventory. I don't have to. But eventually, again, that's going to diminish, and we're going to have to either change the equipment or change over to a different refrigerant.
Yeah. And it's not just about selling new refrigerants. It's also EPA friendlier. Okay. It's better for the, if you, on paper, it's documented, it's better for, or the atmosphere. Okay. So if it does get leaked out by accident, okay, the 513 much better than the 134A. The 449 much better than the 404A. 404A is unfortunately, because of its GWP, it's going to take a really.
I mean, it's so bad that like California hasn't been using it in 5 years or so. I mean, there's a lot of states that are stepping up and said, "Listen, we don't even want that over here anymore."
Exactly.
And we own that product, so hopefully I won't get in trouble with this. It's a great refrigerant. Okay, it's a very good refrigerant. Unfortunately, it with that GWP being that high, it's time.
R12 is an amazing refrigerant. We won't get that wrong. The refrigerants themselves work great.
You just mentioned that. One of my buddies owns a little grocery store.
Yeah.
And I was checking out the equipment, and he's got a box, and it's still running on R12.
Absolutely.
Touched it forever.
Yeah.
Still running, still happy.
Yeah. I mean, I've heard stories. I haven't seen it personally because I don't work overseas and stuff like that. There's a lot of like countries, not that don't have the infrastructure we do that use R12 a lot yet, from what I understand.
Yeah, I've heard some of that.
So it's out there.
Well, gentlemen, this has been an enlightening opportunity. We should charge for this. These classes are so good.
Well, I feel like I should pay you. I had so much fun. I feel like I owe you something.
Now, that's the whole reason that we are here, is because we have this amazing opportunity due to the ESCO Institute and HVAC Excellence to be able to bring education to the industry and to bring some of the top educators that you could ever want to go see are right here, and you have the opportunity to ask questions and just be here with us. And we're so grateful that you've all joined us today. So any final remarks before we wrap it up for the night, guys?
I just want to thank you. Chemours wants to thank you for having us. I appreciate all you do for our industry, ESCO, and I mean that sincerely. You guys are doing a fabulous job with education, and I'm proud to call you friends and to be a part of this. I mean that sincerely.
Yeah, and we're blessed to have a lot of smart people out there to make us look smarter.
And we'll see you at AHR in Atlanta in February, correct?
See you soon.
That is correct. Yes, you will.
All right, everyone have a fantastic evening. We will see you again next week on Did You Know? The ESCO HVAC
Thanks, everyone.
Show.
Take care.
Thank you.
Thank you.
Thank you for joining Did You Know? The ESCO HVAC Show, brought to you by the ESCO Institute and HVAC Excellence. Our mission is to bring the top educators of the industry here for you in a live, unique experience so that you can join us from multiple social platforms, all with the opportunity to ask questions, to be involved, and to learn about the things that are changing in our industry as they are changing. Subscribe to our YouTube channel to get notifications when we go live every week. Are you an educator looking for resources to be the best that you can be? Man, you're in the right place. And we invite you to come join us at the National HVACR Education Conference, where we bring all of these guests and many more, along with manufacturers and different organizations of the trade, so that we can all be in one place at one time and gather this information to make us better together. How do you learn more? Go to escogroup.org, select HVAC Excellence, and then the conference. I look forward to seeing you again next week on Did You Know? The ESCO HVAC Show.